Hello everyone, this is the video lecture for Business Calculus, Math 1325. My name is Professor Burrow, or you can just call me Chad, because that's my name. So, we are going to do Business Calculus here together. I do not have a workbook for this class. I think that's okay. What I did is I went through the homework and I found some questions that were good, representative. Not every one of them. I'd say probably about half or so. So that way you can do some, you can see me do some, and it's going to be great. I'm going to do like a little mini lecture as we go, especially at the very beginning of the chapter whenever we talk about the concepts that we're going to be applying. And that's how this will roll. I'm going to have, of course, Desmos Scientific and Desmos Graphing up, and we're going to be using them a lot here in Chapter 9. So let's do this thing. I'm going to start with limits. And limits, I'm just going to give you some graphical, background to what we're talking about here. Let's say we have this cool curve here, and they're saying, hey, there's this point right here, and I want to find the limit at that point. So, and I'm going to switch some colors on you right quick. Yeah, let's do some kind of pink action. So let's say trying to find the limit as we're going towards that point. I'm following the curve on this side, on the left side, and I'm following the curve on the right side, and I want to end up at the exact same point. And if it is the exact same point, well, then you found the limit, and that's it. So I'm going to zoom in on another one. We're coming on one side, we're coming in from the other side. If we meet at the same point, like on this line, I'm literally on this line here, we meet at the same point, therefore you have a limit, whatever that is, there you go. Now we're going to be looking at y values of those points, because we already know the x value, that's where we're trying to find. I want to know how high is it, what's the y value for that, and that's going to be our coordinate point, etc., blah blah blah. So for the limit notation, it's going to look something like this, and I'm going to go do some examples on my own before we even do a lecture or before we do any of the homework at all. So this is, I guess, your lecture. We got limit as x approaches 3 of x squared plus 2x minus 1. I'm just making something up. They say go ahead and find that. Sometimes they'll use the parentheses around that. Either way, it should be fine. So we have a limit as x approaches 3. So that's x. I'm gonna write the whole thing up. So that's the limit as x approaches 3. Okay. We're trying to get close to 3 on the number line. Here's 3, and we're coming in on both sides. We're coming in from the left side, we're coming in from the right side. We're trying to meet up here in the middle and see what's going on at 3 of this function. Now, this is like your f of x function. A lot of times they'll just put f of x right there. Right here, I'm just giving you a specific example. How you want to do this problem is very, very simple. What you're going to do is say, well, I'm going to say x is equal to 3, and I'm going to plug them in, and we're going to see what we get. So let me do that for you here. I got 3 squared is 9. We got plus the 6 minus the 1. So we have, 8 plus 6 is 14. There you go. We just did our first limit. There it is. That was it. Yay. Very good. So plugging it in, I'm gonna write a little thing here. I'm going to say plug it in. That is the main course for doing limits whenever they're basic, easy. So some more fancy words, I would say, are continuous, when it's continuous on that point. So let's go to something that's not like that. So here's another example where we're going to have issues for our limits. And so I got the limit as x approaches 2 of x plus 3 divided by x minus 2. So this is a little different. Let's just say I'm going to plug this thing in. I'm going to say, x is equal to 2, and I plug it in both there on the top and the bottom. And we're going to get 5 over 0, which we all know is undefined. And it just doesn't work. No limit exists. If they actually did just have this, if they had this on the homework and they said, give me an answer, you'd say it doesn't work, because it doesn't. okay? That's it. You're done. There you go. But there's a little bit more to the math here, okay? I guess we have a page break. So there's a bit more to the math. And so what I want to show you now is what does the graph of this look like? I want to look at the graph, and then I'm going to go and evaluate both sides individually. Again, you have to see this as a number line, and we're coming in from the left side, and we're coming in from the right side, and I want to know what's going on at that point too. Well, let's go to the graph, and I want to see what it looks like. So I'm like shuffling papers out of the way here. We got x plus 3 divided by x minus 2, and this is our graph. Now, I'm hoping at this point you know a little bit about graphs and stuff, since you're in business calculus, but let's just say we don't know too much. This is not continuous because there's a vertical asymptote at 2. So you can kind of see from the graph that this is that dividing line. If you want to be very specific, you can say x equals 2 and see where that vertical asymptote is. So 2 is kind of like a cutoff line between the both of them. And what I want to do is I want to see what the limit is, right? Okay, well, if you come from the left side, I'm following the graph, and it's just like what we did up here, guys. We're just following the graph. So I'm following the graph, and we're going down, 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 down. And then if you go on the right side, we're going up, 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 up. And they're not the same. They're not the same point. So let me give you a little bit more descriptors, more talk about it for these limits. So continuing on from this, let's say that I have x approaches 2 from the left. Notice that I have a little -2. So that little -2 means, or I'm sorry, just -2. That little negative sign up there, it is next to the 2. That little negative sign that's like a power kind of, it means from the left. From the left, okay? That's what it means. I'm only looking at the left side. And so I'm going to just protograph this again so that you kind of like, have like a version over here. And so I'm only here on the left side of this vertical asymptote. This is all I'm looking at. This doesn't exist. I'm only looking right here, and I want to get close to 2. I want to approach 2. So that means I'm going to follow the graph. Follow the graph, follow the graph. Follow the graph, follow the graph. Here we go. Follow the graph. Where are we going? What would you say this is? It's negative infinity. And so my answer is negative infinity. And I know in chapter 9.1, they're not going to talk about that, but later on they will have infinity answers. There's a whole section devoted just to infinity answers. So you will see this again eventually. Now, that was from the left. Now, let's say I went from the right, only the right, just the right, nowhere else. What would it look like? What would I get for my answer? So again, I need to graph it, and I'm going to try to just show you. We have this thing here. We have this thing over here. And again, we have the left, and we have the right. Well, I don't care about the left anymore. I said from the right. That's from the right. And I know my handwriting's bad, but, well, you're going to get used to it. So from the right. And that means I'm going to follow this, trying to get really close to this vertical asymptote. I'm going up, 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 up. What would you call this? Positive infinity. Indeed, there's your answer. Okay. So we found our limits on the left side and the right side. But when we looked at limits, when I said, hey, find the limit, we're always coming in from both sides. From both sides, okay, from both sides. And so did I get the same result on both sides? I know they both have an infinity, but this one's negative infinity, that one's positive infinity, not the same. So not the same result on the left and the right sides, or the right limits, I guess you can say. Therefore, limit does not exist. Limit does not exist. I mean, that's basic. It's multiple choice on this one. You click the other one, you click that button, and you move on. Okay, so I went way, way, way too far on this very simple problem. But I wanted to introduce some of these concepts to you because we're going to be seeing these again here on the homework in a few minutes. Okay, so from the left, from the right, and all this other stuff. Now, is there a way to do this without a graph And yes, there is. So just like we were able to plug in that number here and it works. And I tried to plug it in here and it doesn't work. So is there a way to kind of plug it in? Not, and I made that intentional, by the way, to plug it in and get a result. And so let me show you. This is kind of an interesting take on it. Okay, this is what I would more say is like an approximation. So whenever, man, I always want to put a little one up there. Whenever I am trying to go from the left to the right, and the 2 itself is just not working, what I want to do is plug in a number that's really close to that. So on the left side of 2. So that would be, I'm just taking a stab here, 1.999, okay? So this is what I'm going to plug in, and let's see what happens. So again, I'm going to use Desmos. And let me show you some of the cool things that you can do with Desmos. You can type in this as a function and then just type in like 2. You can see it's undefined. Well, in my case right now, I want to try 1.999. So when I plug that in, I got a negative 4999. Now, this is a big number, but it's still kind of wonky. Well, what if I put another 9 here? And another 9, and another 9. You can see what's going on here. It's getting bigger and bigger and bigger. And so, again, this was just an approximation of what's going on here. It's essentially negative infinity, okay? When I say the limit as x approaches 2 from the right, I want a number that's pretty close to 2 and on the right side of it. And so I'm going to say, for this particular case, I know I don't have a lot of room here, I'm going to say 2.001. So instead of this 2.001, you can see now I got a positive, I'm emphasizing that, positive 5,000 whatever. And if I kept adding more zeros, you can see it just gets bigger and bigger. And so essentially that's positive infinity. Yet again, these are not the same, therefore the limit does not exist, just like what we previously stated. But now you can see that you can use both the graphing, you can use the scientific, and we're going to be using these tools as we keep going. I have to show you the tools in order to get the homework problems worked, okay? So that's that. Now, let's move on. So from here on, what I'm going to do for the homework is these ID numbers from my math lab. So your homework's on my math lab, and you go to 9.1 homework, and it's not number 9 on the homework. I think that this one's just number 1 on the homework, but this is the ID number at the very top. And so let's say the homework is rearranged or it's changed or I delete something, which I did. So if I modify it slightly, what's going on here is that I want to make sure that you get to the right spot on the homework and you're not confused about what we're looking at, okay? So this is technically number 1, but let's go by IDs from now on. Now, this is a very simple question. It says find f of negative 1.5, and it gives us this graph. And I'm going to try to replicate these graphs really nicely because, well, they do such a great job. And it looks something like this. And this is at 2 height, and this is at 2 right there. So it says find f of whatever using the graph. Well, right here is where negative 1.5 will be. So I'm looking at this height. You can see that's right here at 2 height. You put a 2 in, you're done. That's it. That's it. All right, cool. So next question. That's great. I don't think there's much else to talk about there. There's a lot more to go on this homework. So the next question has a graph that looks something like this. That's at 1. And then we have something here at 2. It's solid. It goes down and it comes down. Something kind of like that. And sometimes I don't graph them perfectly like what they have. I just do what's important for what we're talking about. Let me change the color again. And I'm going to, can we do like that maybe? That's cool. So they're wanting to know the limit. And we're going to try to come in from both sides, the left and the right, at, this is 2 here. This is also at 2. Okay, so it says find the limit as x approaches 2 from the left. Okay, so on the left side, again, this is left side. This is right side. This is kind of like our dividing line here. There's not a vertical asymptote here. I'm just kind of saying it's between 2 different sides here, okay? 2 different countries in a way. You know, you got, or 2 different states. You got Texas and Louisiana. There you go. So on the Texas side of things, we're going in and we're seeing that we're approaching, that's the key word, we're approaching this point here. Now I know it's not a solid, but we're just trying to get really close to it. And what's the height going to be? It's going to be at 1, okay? Now they say, hey, we need to go on the right side. So we're only on the right side now. We're approaching it. What would be the height is 2. Again, these are y values here, okay? Now, again, they're going to say, what is the limit? Just like, what's the limit without any little pluses or minuses? Well, again, this one's meaning both, and you've got to have the same number. It's not the same number, so it's not the same. And so what you're going to say is does not exist. Again, it's multiple choice. You'll just click the does not exist button. Like there's a button. You fill it in. There you go. All right, cool. Next question. 9-131. So I've got and again, I want to remind you, I'm not doing every homework question. I don't know what question this one is now. We're probably on number like 5 or something, or 6. So I'm just trying to do a nice representation of what your homework looks like and go through some of them, not all of them. Okay, so it says find the limit of this thing. Now, there's no problems here. I don't see any issues going on. I would just plug it in. And so that is my default go-to guide for most of these. Unless you see that there actually is an issue, just if you see a limit, just plug it in and see what happens, okay? And if you do and something blows up or it's undefined or something weird happens, that's fine. That's a good moment to stop and talk about it and think about what's going on here. So there it is. That was it. Nothing else. Next question. 9-149. So this one is trying to talk about, where was I? Yep, phone calls, they happen. Well, there you go. Anyways, high quality video set here, you know. Okay, so the next question. We got f of 0 is equal to -1. They have this limit as x goes to 0 on the left side of f of x is equal to 3. And then they say the limit as x goes to 0 on the right side of f of x is equal to 3. And they say pick the graph. This is multiple choice, and I think later in this chapter, I start just skipping over the multiple choice because it's multiple choice. I mean, between you and me, you can get it right eventually. But I want to make sure that we cover these topics, especially right here, where it is actually kind of critical. They're saying that we have a point, and then we have these limits. Now, the limits are the same, which it could be something different. That's fine. But they are the same. And again, these are like y values. So I'm saying that the y values are at 3, but yet we have this point here at 0, -1. Okay. So out of the graphs, what we're looking for is that at 0, at x equals 0, that's the point of interest here, where it looks like we're coming in to this point here on both sides at 3. That's at 3 height. And yet, we have a point, like a solid. This is a solid point at 0, -1. Okay, and that's actually the answer. It looks kind of more like a parabola, a little dot right there, and you click it, and then you're done, and there you go. All right, cool. So there it is. Next question. So 9.1.58, I think. That's an 8. I can't tell. It's an 8 or a 0, one or the other. You can tell my handwriting is so good that I cannot tell the difference. Okay. So the limit as x goes to 4 from the right of f of x is equal to what? The limit as x goes to 4 on the left of f of x is equal to what? And then finally they're just saying, hey, what's the limit on both sides? And again, they have to be the same number in order for that to work. Okay, so we have this, and honestly, between you and me, I was a little confused because they look like they just cancel, right? What's happening is that you have a sign change when you shift from one side of the 4 to the other. And you can see 4s are special number, I guess you can say. Solve for x, you get 4, exactly. I think this is called the Heaviside function. I think there's an I in there. I don't know. Question mark. So you can go look it up if you like, but essentially it looks something kind of like this, and that's what we're going to go for here. If you're on the negative side of things, you're going to have negative. If you're on the positive side of things, you get a positive, and there it is. So what I want to do is use Desmos Scientific for this one, and it just makes it a lot easier, a lot quicker. And again, we're going to use our techniques to plug things in. So it says on the right side of 4. So we got x equals 4 undefined. Okay, so we already know that it's kind of weird there. But I want to be on the right side of 4, a little bit more than 4. So like 0, 0, 1. And you can see that we actually got a number. And that's our answer. So not just 1, I'm going to say positive 1. It is a 1, but positive 1 because positive, I'm emphasizing that. On the left side, we're going to try to say something a little bit less than 4. So not 4, but let's try 3.999. You can see that now we got a negative 1. Negative 1. Now, I want to know what's happening with both, and that is not. They're not the same. Not the same on both sides. And so I would say the limit does not exist. Does not exist. Now, that's not just because I plugged in 4 and I got undefined. That's not the case. That's not the reason why here. You could have a limit where they're both approaching, on both sides, they're approaching this point that doesn't quite exist, and yet they can both be approaching it. And if they're approaching it both the same, then your limit exists. So it just does not happen in this particular case. Let's keep cruising. 9, 1, 65. So I've got f of x is equal to 2x squared minus 11x minus 6 divided by x squared plus x minus 42. So it's a pretty big function. They're saying part A, find the limit as x goes to 6 of f of x. Well, you know what I'm going to do. I'm going to plug that dude in. So, I mean, we could probably start factoring and stuff, and that's a nice way to make this problem take forever. I think plugging it in at least kind of tells us a little bit. It's a go-to guide. So if we got like a number, like if we got like 5, you just say, oh, the answer's 5, and you can move on. But because it's undefined, we have to understand what's going on here. Okay, so we have to do a little bit more comprehension. Again, remember that this is on both sides of the 6, right? So as in, if I'm coming in on the left side and the right side, I should hopefully hit the same number. So I'm going to go 5.999. And so I'm going to say that I had x is equal to 5.999, and I got 0.999 for my answer. Let's try the other side. So 6.001, and we got 1.000007. So what number are both of these getting close to? You're right, it's positive 1, and that's your answer. Because again, this was both. It was both. It was both. I'm just like making it weird for you. We got the same answer on both sides. There you go. So this particular case, the point doesn't exist, but when we're approaching it, we're coming in at the same time, same place, same time, that kind of thing. Now, if you were to do this a little bit more mathematically, we should have factored. And in the bottom, I'm suspecting that we have an x minus 6. And if you think about it, we have the 42, so this would probably be a positive 7. That makes sense with the 1 there. Because it seems to me that it's not a vertical asymptote because we're coming into the same point, it probably will factor to have this x minus 6 in the top. Definitely there's a 2 right there in the front. And to make a 6 from here, we'd have a 1. To end up with an 11, we probably have we might have a plus sign. Yeah, it would be a plus sign. I did a lot of weird factoring just now in my brain. I'm not expecting that of you right now. At least, I mean, you probably can. You're in calculus, I guess. But that's not the bigger expectation here right now. You cancel these, you look at this one, you say, oh, I could plug in the 6. So 2 times 6 plus the 1, and then we got a 6 plus the 7. 12 plus 1, that's a 13. 13 over 13 is 1, positive 1. It's, yay, we did it. So that's the true math way to do it. Now you can say your teacher did it the right way. Part B. What? Oh, man. Some of these problems are really long. It's okay. This one's not that bad. It says find the limit as x goes to 0 of f of x. And so what I'm going to do here is I'm going to plug in 0 everywhere. And, well, I got a scientific calculator for that. Plugging in a 0, we get a number. Look, even better, Desmos Scientific gives you a fraction. Bam! So if it gives you an answer when you plug it in, I mean, as far as I know, that's the answer. And I did try it on the homework, and I did get it correct. So there you go. Double checking myself, of course. 3/8 for whenever I plug in a 1, because I already have it done. So I'm just looking at my answers over here. Okay, cool. I think that we only have 2 more questions in this section, so we're getting there. So 9,183. Okay, this one, it was strange. Again, I can't do every single homework problem, but when I see something that like just is weird, then I gotta talk about it. Now, this one looked strange to me, and it said if my f of x is equal to x squared plus 7. I personally recognize this as a difference quotient. I'm going to just write diff quo or something like that, difference quotient, which basically just means slope. And this is a concept in college algebra, that kind of stuff. I don't know if you've seen it or not. I mean, I used to teach the business math 1324 class a long time ago. I used to teach this one a long time ago. It's been a while. But I don't know exactly what you've had and what you haven't. I don't need to go into a big spiel about difference quotient, though. Right now, we're just saying, this is what they're saying. Let's go and do it. And so what I'm going to do is take this f of x, and I need to, like, plug it in or plug this into that and that kind of stuff. So let me show you how this works here, okay? Instead of just f of this, I'm using this function, but right here I'm replacing the x with 4 plus h. So then we have 4 plus h all squared plus the 7. So this is just that little chunk right there, okay? Minus the original with a 4 plugged in. So then I would have my 4 squared plus the 7, and then all divided by h. Forget about the limit for a while, and just as like a shorthand, you could just write lim. Heck, if you didn't write anything, you'd probably still figure it out. But I want to remind us that, yeah, you could put the h equals 0, or h approaches 0, whatever, or not. This right here, we actually need to FOIL out. And this is where, again, I'm wondering where you are in your math skills. Can you FOIL this thing out without me really, doing much for it? I don't know. Like, do I have to show you this kind of stuff? I don't know. But I'm going to do it anyway. So you multiply each term by itself or by each other term, and you're going to get this thing right here, okay? So this part right here, simplified down. Simplified, yeah. It simplified down to that chunk over here. 4 squared is a 16. And I'm using the big brackets because I wanted to separate them. At this point, you can probably just use parentheses, and it's fine. I just wanted to say, like, hey, it's this minus that, because, I'm doing 2 big chunks here, basically. So I'm going to distribute this minus sign, and what happens is that I get a negative 16 and a negative 7. Well, here I got a positive 16 and a positive 7. So what happens is all of these cancel. How nice. 8h plus h squared all over h. So I want to cancel h everywhere, so these 2 cancel and one of them cancels here. I guess, like, again, I don't really know where you are in your math skills, So I have to stop and pause and do some of this kind of thing once in a while. You cancel these and you cancel those guys. You have an x plus h. And well, there you go. Now, we're not quite done because if you remember, I did something a little bit wrong here. Limit, limit, limit. Oh, I didn't do it. Limit, limit. And again, that's h goes to 0. So I'm saying that the limit as h goes to 0 of this stuff, well, that means plug it in. And 8 plus 0 is 8. All that for 8. All of that for 8. Well, it happens. And there you go. Welcome to business calculus. So the very last question, here we go. This has a table. And I got to say I was confused about this for a few minutes. It actually is going to take me longer just to write this table than to explain it. So let me get through all of this here. While I'm doing this, I want to say that I did not make this homework, okay? I did not. I am here just because I was told to do this. So I'm doing this, and I'm happy to do it, of course. But a lot of times, I probably will show some frustration. I did all of the chapter 9 work just today. So I went through every single homework section. I basically did all the homework today in one day, and I guess in like just a few hours. It was, I don't know, probably about 5 or 6 hours. But you know, I'm an advanced mathematician at this point, right? I'm your teacher. I've been doing this. I taught this a long time ago, and all this stuff. But it was very difficult for me. There was a lot of very frustrating moments, and where I did not know what they're asking for. That's why I'm here. I'm here to tell you, hey, your homework is sometimes really, like I want to use even worse words than that, but your homework is very aggravating. I'm here to tell you, hey, you can do this. I know you can do this. It's just, we got to get through some of these weird ones. I'm happy to do some of these basic limits right up here. That's pretty cool, okay? This dude right here, not too bad. It is a little confusing about what they're wanting. So we have all these dollar amounts for different amounts that you're spending or something, and you get a discount if you put in this much money, etc. So that's kind of nice, I guess. How are they using this math here? And they have, at first, like part A, they have a lot of boxes for what kind of formula you're going to be using for each one of these discounts. And so if there's a 2% discount, that means that 98% is left over. Therefore, your function would be not 0.98x. 5% discount, 95 is left over. A 7% discount, 93 is left over. A 10% discount, 90 is left over. 0.9 times x. This is your part A answer. I think the very first one was like a 1x. It's 100%. But regardless, this is your answer. You type in what you need to get that part done. Okay, so you got that. Now, they say find the limit as x goes to 1,000 on the left side. Okay, so this is on the left side of 1,000. So in a way, we're saying like $999. That's kind of what we're looking at here. Well, that would be in this category right here. Sweet. And so I'm going to use this formula right there. Cool. So in a way, I don't want x equals 999. I mean, that's great, but it would be like 99.9999999, right? I think it would be easy in this case to just simply plug in the 1,000 for this function here. So we have a 98 times the 1,000, kind of just like skipping to the end here, and I got $980. There's your first answer. Well, your second, because that's part A. So this is part B. And then they say, hey, find the limit as you go to 1,000 on the right side. And so technically I'm saying I got like $1,001. That's kind of like what we're looking at. So if you go to which category, it's actually now going to be here. We're looking at this formula now. Okay. So instead of trying to go down that road again, because it's technically 1,000.000000001, And you can plug that in if you like. It's way easier just plug in 1,000 into this new formula, and we get $950. There you go. You just did it. Now, the last part, I believe, was what happens literally at 1,000. Again, on both sides. I want to write both. And what do you get? Well, they're not the same. And therefore, the limit does not exist. There you go. That's the end of this section. That was actually a pretty brief section. Some of them are get a little bit longer, but we are done with that. So thank you very much, and have a great day.